Yeah, we'll go over the website. Probably should give a brief introduction about thyself. But pretty much for this talk, all you need to know is that yeah, you can add me on LinkedIn, find me on LinkedIn. So you actually know why am I talking about all this stuff. We will have the bot transcribing. We'll have the, yeah, we turn on the robot transcribing my voice just to see later how we can improve the tools, improve the talk. So we do this talk, we will cover the content on the website. I'm the developer of BioniChaos.com. Okay, we're having some noise, drilling noise outside. So might actually use the robot to do some introduction and stuff.
Certainly. Let's go through the tools and sections of the BioniChaos website, focusing on the content without worrying about the HTML structure or scripts. Overview of BioniChaos tools and resources. 1. Ethics and AI section. This section explores the ethical implications of AI in biomedical applications, especially concerning brain-computer interfaces, BCIs. Advancing Neurotechnology, the impact and ethics of AI-enhanced brain-computer interfaces, discusses advancements in
Yeah, nothing works today. The ChatGPT voice just stopped working. Don't know why. That's not a good start, is it? There's someone drilling outside. We have ChatGPT playing up. The voice is playing up and not letting us record anything. It's a bit, my microphone's not sensitive enough. Seems like I'm using the wrong microphone, something. It should be correct. Okay, now it's too sensitive. One, two. 1, 2, 1, 2, 1, 2. Sorry for that. To actually manually select it. 1, 2, 1, 2, 1, 2. Yeah, now let's see. 1, 1, 1, 1. Yeah, the threshold is pretty low. Okay, then I think the noise is actually not coming through. It's only when I'm talking. Yeah, let's say those are just blogs. So yes, go read them. There's nothing to actually present, but yes, that's the type of content we are interested in. Yeah, ethical concerns with the neural implant of a high interest. The controller, the slider there looks differently on different browsers. That's okay. We do want to change the default value on page load. Actually do it straight away so it's a bit clearer. So in the validation there are clear examples of the difference between seizure and no seizure. So this is a seizure detection project. You can go read this page. I'll pop this in the chat so you have the link handy. So you have the link handy. But yes, we want the selected dataset to be validation instead of training, and we want the default to be somewhere through the midline of the scroller. I think it will be a bit better. In templates. Yeah, we want validation as selected option. Can you turn validation into the default selected option? Okay, accept. The scroller. Why is it maximum of 1? It's obviously being updated. In the JavaScript. Obviously being updated in the JavaScript. Yeah, max is being updated. And then we're selecting one. You can actually run it locally. Let's run it locally for a sec. The initialization of the page. The value is already set in the HTML. What? Okay, should we change it manually here? Let's have the drop down. No. So we have validation. And let's go for 100. How many bullets? No, there are 30 from memory. I think 15 should be right in the middle. It's not cool. It's not called validation, is it? It's called val. It's called val. It can be a 15 should be halfway through the thing. Right. Let's set this. Okay, this is actually better. Yeah, so I didn't give context of what's what. we have to mention that the run 9 gave us better results than run 10 of the training. My microphone might be way too sensitive, is it? Yeah, never too sure. Yeah, that image is way too small as well. This is the all the misclassified images. There are 6 in this case. Like this, you can't really see the details. It is better. So in this case, a validation dataset will be loaded up by default, and then this is halfway through the image stack. And in this example, it's much clearer which one is which one is non-seizure and which one is seizure. Seizure is the one that has those patterns in it. That number is 276. There's 600 images all up. So I guess I'm pretty sure the name of the file will be just that is the number out of 600, but then they split through. I think most of them are in training, and then you have 30 or 60. You have 30 of each, so 60 images in test and 60 images in validation. No, sorry, 30. Yeah, so 30 seizures, 30 non-seizures in validation, 30 seizures, 30 non-seizures in test, and the rest of the 600 images are in training. So you can scroll through it, see what's what. Yeah, so we'll update it when actually deploying the site. See if EG2 music still works. Is the tab muted or something? And no. Oops. That's what seizure sounds like on channel 7. Well, that's what seizure sounds like. Just in case you were wondering. And of course you were wondering. This one actually tell you which note was played. Yeah, so it's actually playing multiple notes at once. This meant to be right. So each note is the power so this what sounds the same time point on different channels. So this actually has more seizure visible in it. 6, what was it? 12. So it's the theta wave that is causing there's more theta. It's the orange one around 4 to 7 hertz. It's supposed to, so there will be less of it. The power, wait a second. Yeah, 200. The y-axis there is auto scaling. Yeah, so 12 has in the 15k power. The power is not calibrated. It's not absolute. It's relative power. Can change the window size. So this is the seizure onset bit. Yeah, this is what the whole seizure looks like on channel 1. This is channel 7. There's some weird bit at the end. Channel 12 has more spiking. So if we take about 10 seconds. So this is like before seizure. It's actually auto. Maybe not. Sorry for that. Yeah, so here you have limited theta. It's relative to other components in the DG, and when seizure starts, the ratio between theta and other bands, frequency bands, is higher. So you have more theta, and that's why it sounds different as well. And you can go play with this tool yourself. If you find any bugs, do let me know. I'm actually trying to test my sound. Oh, why there's something wrong with my microphone, or the fact that I think it's the fan coming from my server. When I'm actually doing something on the screen, it becomes worse. It becomes worse. And it's getting fed straight into my microphone, which is not nice, is it? Yeah, like now when I'm talking, yeah, there will be more noise coming through the mic. Coming through the mic. Yeah, this tool need more improvement because it's a bit slow. It's using too many resources. It's actually talking to the server, so there's a lot of backend stuff happening, which is not nice. So I have to pay electricity. Yeah, and while using it, my stream actually drops frames, which we don't like, do we? Don't know how it will actually sound like in the video itself. Actually check it. Yeah, that's the thing. When I'm actually showing something on the screen, yeah, the problem is I'm using too many. I have to keep adjusting the darkness threshold for the eye tracker for it to actually work and show something useful. Yeah, like for a presentation, I might have to actually record this and do the video and the demo separately. Sorry, the final video of the talk, there will be the image, the video on the screen, which probably should be just a recording. Yes, when I do this, I'm losing frames in my stream because this tool is taking essentially too many resources. That's not good. It's missing the eye, missing the pupil, missing everything. Yeah, there is apply changes, a new function in GitHub Copilot. But last time I tried it a couple of weeks ago, so it wasn't actually working properly. Let's see if it's working now. When I copy, yeah, when copying it actually works, but when using that apply changes button, you can't see it on my screen. Anyway, when GitHub Copilot is a bit funny that way. Hey, can you also check if all the data points are plotted in the same size all the time or not? The data points drawn, small circle, green circle. Yeah, the radius of the circle is 4. Yeah, it's meant to be. Yeah, we have the old version of the code 483. The new one is shorter. Don't know why. Yeah, the more greens, green dot points added, even though I'm not interacting, is because the ones that normal ECG waveforms, I'm not supposed to click on them, so those will produce. Yeah, if I click on one, it will produce red. It's one green, and the interpolation line is not really updating. It's having trouble interpolating. Have cubic, no. Linear, yes. Polynomial, that's interesting. Why is it so low? Cubic spline, linear, 0.0, a 0.008 and polynomial 0.015. Okay, this still should be closer to 1. It should be above 0.5. It should be this area. Yeah, there's a problem with the area calculation. Are there any placeholders in the code? Yeah, GitHub Copilot is a bit silly. It's not as smart as the GPT-4. Are there any placeholders in the code? It says there aren't. We need to check. Which bit of the code is responsible for calculating the area under the curve? And we calculate AUC function. It checks if there is enough point, initializes the AUC, sets the initial value to 0. Should the initial value be what the initial value should be? It should be 0.5. No, I mean 0 makes sense. It still should go to. So what the maximum value can be of the area under the curve? It should be, the answer should be 1. Yes, it should be 1. The values we are getting, say for the polynomial, is too low. Let's restart it quickly. It should be green. It should be another green. So the score goes up. Yes, score goes up. Yeah, that's that line there. Okay, if we don't respond to that one, this should be red. Yep, it's that red there. Click on this one, should be red as well. Okay, now this area seems to be too large for it to be 0.1. It should be close to 0.5. 0.165. It's not going up as well. Okay, this going up. 192. 192. Okay, it's a bit weird. The points seem correct. So as the more correct responses, the line, the area should go bigger. It's not changing. Yeah, weird. This is weird. This is weird. So I get it, it's not as sensitive. 197. Should we add more decimal points? Well, we shouldn't have, because it should be going from all the way from 0 to 1. 0, it's that line being along this one. 0, 0 to 1, 1. Diagonal. Then should be growing if we have correct responses. Yeah, we should have clicked on this one. 6. Yeah, it's not changing much once it's kind of set. Okay, another thing is when we add the new line to the chart, can it be, say, double the size, so we can actually tell which one was the last data point added to the rock curve? So it's updating draw rock. Updating draw rock. the size. Let's copy the whole thing because the integration button didn't work in the past. So we should be trying it again. Let's start a new one. Okay, we have the size obviously bigger there. Let's not click on it, so we get a red. Yep, we get a larger red, get a larger green above it. That's right. Should get a red for this. Yep. Hey, we can get another red for that. Okay, so now we actually have the value for the area under the rock curve. Doesn't make sense. 0.1, 0.19. 0.1. It went down. Why? Should have the like all the monitoring of the values that we would like to check. But I'm thinking, yeah, GitHub Copilot might be not intelligent enough to sort this out for us. So we might use a ChatGPT. Let's start a new chat quickly. Don't really trust it as well. The project structure. We have the last. So yes, it needs to know we are dealing with a Flask application. Yeah, we have the waveform. A JS, it's generating all the waveforms. We have the style, which we don't worry about at the moment. We have some description. Yeah, we'll leave it there for now, but we might need rewriting it. The main thing is this JavaScript. Should we just send it with no prompting? We have the application running on the website already. It's in development section. But we are trying to make it better. Yes, sound effects sound good. When we click on the waveform, yeah, to improve engagement, sounds great. How difficult would it be to implement? The waveform generation is fine at the moment, so the waveforms look okay. Yeah, great educational tool. Thank you for the feedback. Yeah, we might need to check the calculation of the area under the rock. Can you actually try and tell if the current area under the rock calculation is correct or not based on the image provided? Okay, a couple of things. So first, yeah, if we can actually go over the code in detail and verify that the current area under the curve is calculated correctly. And that would be great. Now, regards the sounds, the sound effects, I don't have MP3 sounds, MP3 sound files. So any suggestions are welcome. I don't need to log in to download it though. It's Creative Commons 0, which is nice. Yeah, I want to add some sound effects to. Can Python actually? I'm pretty sure you can do it with some sort of library. But yeah, mainly we want to focus on getting the area under the curve calculation correctly.
Let's go over the code to verify the area under the curve AUC calculation in detail. Understanding AUC calculation logic. In your current approach, you're using a trapezoidal method to calculate the area under the ROC curve. The AUC is the integral of the ROC curve, which is calculated by finding the area of small trapezoids between successive points on the curve, false positive rate FPR on the x-axis, true positive rate TPR on the y-axis. 1. ROC points. In the function update ROC, you correctly calculate the true positive rate TPR and false positive rate FPR based on hits, misses, false alarms, and correct rejections. 2. Storing ROC points. These ROC points, TPR, FPR, are stored in an array called ROC points. JavaScript ROCpoints.push, TPR, FPR, correct. 3. Sorting ROC points. Before calculating AUC, the points are sorted by their FPR values to ensure proper trapezoidal integration. JavaScript ROCpoints.sort a.b a.fpr-b.fpr. For trapezoidal calculation, the AUC is computed by summing the areas of trapezoids between consecutive ROC points. JavaScript for let I equals 1, I ROCpoints.length, I++. Const x1 equals ROCpoints I minus 1, FPR. Const x2 equals ROCpoints I.fpr. Const y1 equals interpolate yx1. Const y2 equals interpolate yx2. Const trapezoid area equals y1 dice mid y1 y2 is mid y2 x2 dice x1 2. AUC plus equals trapezoid area. Shar key points to verify. 1. Sorting by FPR. Ensure the ROC points are always sorted by FPR in ascending order before the AUC is calculated. This is already happening, but adding an extra check after sorting is a good idea to confirm. 2. Interpolation function. You're using different interpolation methods, linear, spline, and polynomial. Check whether these interpolations correctly compute the values for the ROC points. Linear interpolation. This should work fine for a small number of ROC points. Make sure the interpolated values fall between the valid range of 0, 1. Spline and polynomial. These methods are more complex. Ensure the interpolated values do not introduce significant distortions, i.e. they should stay within the range 0, 1. 3. Ensure TPR and FPR accuracy. Verify that TPR and FPR are correctly calculated. For TPR, true positive rate, it should be text TPR equals frac text hits text misses. Similarly, for FPR false positive rate, text FPR equals false alarms correct rejections. 4. Edge cases. When there are fewer than 5 points, AUC returns null, which is fine. However, you may want to handle this more explicitly in your game, displaying a message like insufficient data for AUC. Our improvements. To make sure the AUC value is calculated correctly, you can log each step of the trapezoidal integration process for debugging. JavaScript for let I equal 1, I ROCpoints.length, I++, const x1 is ROCpoints is1 FPR, const x2 equals ROCpoints I FPR, const y1 equals interpolate x1, const y2 equals interpolate yx2, console log trapezoid between FPR x1 $x2 and TPR y1, const trapezoid area equals y1 is mid y1, y2 mid y2, x2 next is x1 r2, console.log.
Yeah, well, it's reading the code as well when doing the text to speech. Anyhow, when you ask a GitHub Copilot, you want to sort the ROC points, have a false positive rate in ascending order before AUC is calculated. So that's not happening currently in the code, is it? know how to interact with this thing. Yeah, it gave me that already. What's the point? Let's actually test that. Should be green, that's right. Let's do a bunch of greens. So the true positive rate is 1, false positive rate is 0. That's perfect response, and that's why it cannot calculate the area under the curve. Yeah, we need a few of those. It's funny how it's ignored the red one. Oh, now it added it. Okay, we have a true positive rate 0.4, false positive rate of 0.3, but the area under the curve is 0.065. There's something really wrong in that calculation. Okay, what else do we have in the suggestions? It's a regular text. So if we select the whole code, no, it's not. Yeah, the sound effects instead of yeah, I don't want to log in. The sounds look great, but surely we can have Python script generating sounds for success and failure. But more importantly, yes, we would like to make improvements to the code in terms of how and make sure that the area under the curve is calculated correctly, but I might need help with the code. This is the script that we currently have. Any suggestions are welcome. Can you summarize in plain text, optimize for text to speech? We are live streaming at the moment, and also invite write an invite to join this live stream session. Can you improve the invitation to join in with the more specific, more technical features of what we are doing in this session?
Sure. Here's a text-to-speech optimized summary for your live stream. To ensure that the area under the rock curve AUC calculation is accurate, we need to focus on verifying the correct true positive rate, TPR, and false positive rate FPR values. This involves sorting the rock points and calculating the trapezoidal areas between them. We can add logs to track the trapezoid areas during the game. This will help confirm that the calculations are happening correctly. As for the sound effects, we can use a Python library called PyDub to generate simple success and failure sounds. These sounds can then be triggered when players correctly or incorrectly identify an abnormal waveform. This adds an interactive element and boosts engagement. To all viewers, feel free to join this live stream session. We're discussing game development, biomedical signal processing, and interactive features like sound effects and real-time performance feedback. You're welcome to provide feedback and ideas while we work on this project live. Join us and be part of the conversation. Let me know if you'd like to adjust or add anything. Of course, here's an improved invitation that's more specific to the technical features you're working on during the session. Join our live stream session where we're building and improving Cardio Rock, an interactive game that challenges players to identify abnormal ECG waveforms in real time. In this session, we're focusing on enhancing the AUC, area under the rock curve calculation, ensuring that it accurately reflects the player's performance. We're also adding dynamic sound effects triggered by player actions using Python's PyDub library to generate custom success and failure tones. This will make the game more engaging by providing immediate audio feedback when players correctly or incorrectly classify ECG waveforms. We're diving into technical concepts like trapezoidal integration for calculating the area under the rock curve, interpolating rock points with different methods like linear, spline, and polynomial fits. Real-time performance visualization through a dynamic Rossi curve that updates with every click. Adding custom sound effects to enhance player engagement and immersion. Whether you're into game development, biomedical data visualization, or just curious about how we're bringing these medical signals to life in a fun and educational way, this is a great chance to see the process in action. Come join the discussion, share your thoughts, and help us refine this project live. This version emphasizes the technical aspects of the session while inviting viewers to participate in the development. Let me know if you'd like any more changes.
Try to verify and improve the area under the curve calculation. Yeah, we're using trapezoidal rule. Blah blah blah. Calculate rock points. Codes seem correct. Do we potentially now have the sorting happening multiple times? No, wait, in the calculation. Yeah, doing more debugging. So logging over here, are we? Maybe. For the sound effects, try to generate them programmatically. Generate sound files Python script. PyDub and fmpeg. Yeah, so it knows what's a success failure sounds should sound like. Handle handle click in JavaScript. Yes, we do. It's of course will not work at the moment. Anyway, now I have the trapezoid areas. And it's always 0. Why? The trapezoid areas and what's that area that appears and then disappears? Might be to do with the heat sound being absent. That value actually makes more sense. Yeah, but why the trapezoid areas are 0 all the time? The trapezoid areas are 0 all the time. The trapezoid. Pretty sure I'm not using the correct microphone. No, it is the correct microphone. So the trapezoid areas are 0 all the time. Any idea why? Let's actually stop this for a sec. What's the okay, that's pretty annoying, but
The issue with all the trapezoid areas being zero Frouth, though, is likely due to the fact that the x1 and x2 values, FPR, are the same for many points, which means the width of the trapezoid becomes 0. When x1 ton equals x2 do, the formula for the area of a trapezoid results in 0 because the height of the trapezoid has no width to spread across. This seems to happen because your Arasi points, particularly FPR values, are clustering around the same values, such as 1.0. This suggests that the false positive rate, FPR, isn't changing much over successive points, which causes the trapezoid base to be 0, and thus the area is 0. Potential fixes. 1. Ensure FPR is calculated dynamically. The FPR should vary as the game progresses. If FPR stays constant for multiple points, it could indicate that false alarms and correct rejections are not updating correctly in the game logic. You can add more logs to verify how false alarms and correct rejections are being updated. Make sure these variables are incrementing properly as the game progresses. 2. Add a minimum difference for FPR. To avoid 0 areas, you can add a condition that ensures FPR values differ by a small amount. For instance, you could introduce a minimum threshold to ensure that x2 is always larger than x1 by a non-zero amount. JavaScript, if x2 minus x1 0, const trapezoid area equals y1 plus y2 to x2 night, swing trapezoid area, console.log trapezoid area, else console.warn FPR values are too close or identical, skipping trapezoid calculation. 3. Handle identical points with a small increment. If you frequently get identical FPR points, you can introduce a small increment, epsilon, in the calculations to avoid zeros. JavaScript const epsilon equals 0.0001 if maths x2 minus x1 epsilon, x2 plus epsilon. Adjust x2 slightly to avoid zero width trapezoid. 4. Check data update logic. Make sure the points are being added to rock points correctly and that the game's feedback system, whether it's a hit or miss, is triggering an appropriate change in TPR and FPR values. Next steps. 1. Add some logging to verify how false alarms and correct rejections are changing over time. They might not be incrementing properly, leading to flat FPR values. 2. Ensure that FPR and TPR values are updating dynamically as the player interacts with the game. This will allow the trapezoid areas to reflect meaningful differences between points. Try adding the suggested threshold check and logging, and see if the trapezoid areas start varying properly. Let me know how it goes. The issue with all the trapezoid areas.
Yeah, we'll have to finish now. Don't forget to check the website. All the tools that we currently developing during the live streams will eventually appear on this site. So don't forget to provide your feedback, and I'll see you next time. Bye.